Good morning, and first, thank you for having me here. It's a pleasure. I'm responsible for research and development at SunPower Corporation. I'm going to give a quick introduction to SunPower here for people who aren't aware. SunPower is a leading PV company. We're global, worldwide. We serve all the markets: residential, commercial, and large-scale utility. We have a #1 position in the U.S. in residential and commercial through a dealer network. We have about 1,500 dealers. Recently, we are building a 250 megawatt plant nearby, near San Luis Obispo, called California Solar Ranch. I'll talk about that a little bit in my presentation as well. Okay, like I said, we go to market in 3 different channels worldwide. The core of our offering is our cell. We have a high-efficiency cell. It was developed in the 80s and 90s, initially as a concentrator cell. That cell platform was then deployed in a one-sun format, or a conventional PV module format. But the heritage of this cell is in concentration, which is why you see no metal on the front. It's one of the only cells you'll see. It's a crystalline cell with no metal on the front. And that is then deployed in a number of systems. We do a fair amount of R&D work in balance of system work as well. SunPower acquired a company called Powerlight in 2007. Powerlight was an innovator in that area. So we have some very unique products that we offer in the balance of system area, and I'll talk about those as we go on as well. As far as our work with the DOE, I was asked specifically to talk about SunShot, so I will. We've got a long history of collaboration with the DOE. The DOE has been a huge supporter of SunPower's over the years. Over the last 3 years, we're just now wrapping up a program that the DOE supported us on. And out of that came a number of commercial-ready products. T5 is a commercial rooftop system. It's an integrated PV system with a mounting system attached to it. It's a polymer mounting system. It is assembled on the commercial roof, so it's for a flat roof, by hand, no tools required. And it doesn't require attachment to the roof, so you can just rest it on the roof. There's been a lot of aerodynamic testing. It doesn't blow off the roof. So it's a very, very innovative product. It's been tremendously successful for us. We also, through DOE support, developed a lot of automated manufacturing equipment that allowed us to economically put a module manufacturing plant in the U.S. So we opened that just a couple weeks ago up in the Bay Area. It also supported the development of a 24% efficient solar cell. That cell platform, that architecture, is now being put into production. I'll show you some results from that as we get into it. And that cell and some other innovations actually generated a greater than 20% efficient module. And that's a world record. Well, not a world record, but as it becomes commercialized, will be the first commercially available 20% efficient module. Okay, so the SunShot program is. This is how it's laid out. Ramesh showed this to us. When we saw that, we said, well, we're up for pretty much any challenge. Is this a challenge we can make? So the first thing we did is look at this experience curve, and this has now been shown a few times. If we go back to 2002, so right here, and say, okay, let's project forward what we think is going to happen as production increases. We think in 2010 we'll be at about 220 a watt, and by 2013 we'll be at about $1.75. So where did we end up? A few things happened. First of all, we broke away from the learning curve here, and prices actually went up. That was caused by a silicon shortage in the industry. So this is largely crystalline silicon. Crystalline silicon still makes up a large portion of the industry. And right around this period was the first time that PV, the consumption of silicon, was dominated by the PV industry versus the semiconductor electronics industry. And that, of course, has continued. So this period is a ramp up of silicon production. And as that silicon production came up, you can see the prices drop right back down to the learning curve. In fact, because the silicon was high, people innovated a lot to maintain the cost decrease. So then we say, well, what does the SunShot goal mean if we were to believe this experience curve? And if we believe this, in order to get to the 50 cent a watt module price, so this is a module price graph, by 2017, industry's going to have to grow or deploy at a 50% average growth, annual growth rate. And by that time, there'll be 880 gigawatts of cumulative production deployed. So that, in addition to the cost, that's a monumental target. That's a very, very aggressive target. I think that we'll all be extremely happy if this happens. So what's SunPower doing about this? SunPower, as I mentioned, our position in the industry is one of high efficiency, but we've been driving costs very aggressively as well. And I think we're coming from a position where we have a lot of opportunity to drive costs. So this is our historic cost, this is our module cost, historic cost roadmap, our actuals. And then what we're committing to, so right now we've got a commitment in 2014 to be at $1 a watt module cost. And that would be at a roughly 21% efficient module. And efficiency, as I'll talk about later, has got a lot of leverage in system economics. So how are we going to get there? I'll talk a little bit about that. We're going to do it through increasing our scale. Scale is actually a big driver of cost for us. Technical innovation, improved silicon wafering technologies, improved cell processing capability, and improved cell architectures. Scale. So scale is a big deal. This is a manufacturing plant SunPower's building right now. The first half of this is now completed and is in production and ramping. It's not entirely in production. This is a 1.4 gigawatt plant. It's been under construction for about, probably 18 months now, and the project has been underway for 2.5 or 3 years. It's a monumental effort to build a fab like this. When it's done, it'll be the single largest sited plant at 1.4 gigawatts. This is going to give us roughly 2 gigawatts of total installed capacity worldwide. So that would be a big step for SunPower in terms of volume and scale. And the scale gives us a lot of opportunities to improve our efficiencies, operating efficiencies, reduce our cost. But this is a monster effort. And if you go back to this and say, okay, we've got to get to a huge amount of production to achieve these goals. And if we're going to do it by building factories like this is going to be this is going to be a big challenge. I think the reason you see scale problems, now the PV industry has scaled aggressively, but it's very, very capital intensive. And so this is a challenge. This is a challenge we're going to have for sure. Cell efficiency. This is, I mentioned the 24% efficient cell that we produced with the help of DOE. This is the distribution of our cells in production. We're now on our 3rd generation cell, which we wisely call Gen 3. So the Gen 1, you can see a couple things I'll point out here. The width of the distribution is kind of an indication of your process control and the precision you operate at in your factory. This is a challenge. This is going to be a challenge for companies as they try to increase their efficiencies in their factories. And we learn from, this is really factory 1 where we deployed this. This is our factory 2, and this is now a small line in factory 1. But you can see as we increase efficiency, naturally the width gets narrow. And that's because you require better and better processing capability to achieve those higher efficiencies. So this is our Gen 3. It's you know, pushing 23.5% efficient. I think we'll see that climb as it's not even in limited release yet. This is just from early engineering runs in the fab. But this is data coming out of our factory. And you'll see this move to the right as we put that into production. We expect to get that into production later on this year. The other thing about silicon, and Ryan talked a lot about silicon versus thin film. Silicon, for us, we think we can get very good efficiency at very thin silicon levels. So down to 50 microns of silicon will give us really very high efficiency as well, close to 24% efficient. And that's something that we think is really going to help, through innovation, help us drive our cost structures down. Now, when I read the DOE dollar a watt white paper, which I read again as I was preparing for this, there's a slide in there that talks about what's the crystalline silicon opportunity. And this is what the white paper laid out as the crystalline silicon opportunity. And I read this, it was interesting, and some other people at SunPower, you know, so this says in 2020, all rear contact, all back contact, 20.9% efficient module. That's where we are right now. We actually have this is a product we ship. Our cost isn't quite there yet, but we're driving to that. And we can do that I think we've got a roadmap to that. The next thing is, you know, this is right in line with our roadmap, so I think we're consistent with that. I think the point that I want to talk about next is what you can do beyond just the module to improve system economics. And one thing we do on systems is track, and I'm going to talk about that a little bit. So we do think that this goal is aggressive. I think we admire the leadership of the DOE to put it out there to drive PV companies to reduce costs. It's something we're doing anyway. But it's great, and I appreciate the DOE's leadership and collaboration to achieve that. So a couple things about the value of efficiency. So this is just a very simple analysis. It's not meant to be anything directive about cost or anything in this, but to look at a high efficiency product like SunPower and a thin film product. Efficiencies would be, you know, roughly 20% for the SunPower product and roughly 11% for the thin film product. Now, if you take those two systems and you build a power plant with it, this one would be a tracking power plant. This one is a fixed tilt power plant. First of all, you can notice the size difference. This thin film takes up a lot more space. That's important. The second thing is that this tracks, which means it produces more energy per kilowatt than this system does. And because of that, for the same investment, $200 million, you can generate 100 gigawatt hours per year. And when you back calculate what the system cost is, you can see the value right here of that efficiency and of tracking. And the high efficiency module allows tracking to be economical. So that's just it's a bit of a nuance, but it's important when you get into large systems. So this is the California Valley Solar Ranch system in California. And I'm just going to quickly talk about an experience we had there. So this is how the system is laid out today. This is more or less the final system. We went through a number of iterations of the system to get to this point. And a couple things to note. This was driven by a lot of different things. There's a lot of wildlife issues that needed to be addressed at this site, a lot of environmental issues that needed to be addressed. We redesigned this, I think, 20 to 25 times as we were doing this, and we're ultimately still able to get to 250 megawatts. I doubt that we would be able to do that if we had a lower efficiency module. I'm sure we would not have been able to do that. And you can see that the size of the system, when somebody decides to do a power plant, gain as much capacity onto that plant as possible is a big deal. Now, a couple things on the balance of system side I want to talk about. First is Oasis. Oasis is our utility power plant system. We call it a productized or standard power plant. Now, Ramesh or Ryan, I'm not sure who, talked about, you know, electricians rewiring things and stripping wires in the field. That does happen. It's very expensive. So what this is meant to do is address this as a product. So everything is pre-engineered, pre-designed. It shows up on site, and in site engineering time, site deployment time is minimized. Okay, the last thing I want to talk about is I think a more innovative approach to cost reduction for us, and it addresses a lot of the issues that I brought up as I went through this presentation, issues like scalability, silicon utilization, manufacturing capacity. So SunPower has developed a CPV system. I mentioned initially that SunPower originally was a CPV company. This is a CPV system based on SunPower's standard cells, slightly converted to perform under concentration. So these are not the 40+% efficient cells Ryan talked about. These are roughly 24 to 25% efficient under concentration. They're low concentration. So this is a 7x concentrator. By making a 7x concentrator, that does a lot of things for you. One, it means the requirements for tracking in the field are much reduced. So you can get by with a lot less precision in the field. And in fact, we do this without any field alignment. The system just snaps together in the field. From a capital efficiency perspective, that plant I showed you, 1.4 gigawatt plant, would be 14 gigawatts at 10x. So that allows us to achieve the scale that we're trying to achieve without continuing to put all of our cash flow back into building new capacity. It's a really, really big deal. Silicon utilization, the amount of silicon per watt is reduced by the concentration factor. So that's, again, it addresses that material usage, silicon usage. LCOE, we think this system, when it reaches maturity, will be roughly 20% better on a cost perspective than a traditional flat plate tracking system I talked about earlier. Challenges bankability. This system uses only materials already being shipped in production today. So we're very, very excited about that. The other thing, as we talked about, I think both Ramesh and Ryan talked about the U.S. manufacturing base. The other thing that this does, I think, is really, it's built around the notion of a regional manufacturing, where really, almost everything can be manufactured locally. For certainly, all of the larger parts of the system would be manufactured locally using, in standard industry, automotive manufacturing processes, et cetera. Okay, so what else do we need to do to achieve these goals? Well, there's a lot. This is not an exhaustive list, but I think the support we need is really around continuing to create a market that allows people to invest. We saw what happened in the earlier discussion on biodiesel. Same thing has happened in PV. Long-term industry is really going to make companies invest for the long haul. Some of the things the DOE is doing with loan guarantee programs and continued funding, I think getting new technology, supporting new technology, getting into the market is going to be critical to get our costs down. And then reducing permitting costs are also going to be a big deal. So that's it for me. Thank you.